Welcome to the 28th video for looking through all of VisionOS documentation made by Apple. We're going to look at the article, Bringing Your Existing App to VisionOS. Build a version of your iPadOS or iOS app using the VisionOS SDK and update your code for platform differences. If you have an existing app that runs in iPadOS or iOS, you can build that app against the VisionOS SDK to run it on the platform. Apps built specifically for VisionOS adopt the standard system appearance, and they look more natural on the platform. Updating your app is also an opportunity to add elements that work well on the platform, such as 3D content and immersive experiences. In most cases, all you need to do to support VisionOS is to update your Xcode project settings and recompile your code. Depending on your app, you might need to make additional changes to account for features that only found in the iOS SDK. While most of the same technologies are available on both platforms, some technologies don't make sense or require hardware that isn't present on VisionOS devices. For example, people don't typically use a headset to make contactless payments. So apps that use the proximity reader for framework must disable those features when running in VisionOS. If you use ARKit in your iOS app to create an augmented reality experience, you might need to make additional changes to support ARKit in VisionOS. For information on how to update this type of app, see Bring Your ARKit app to VisionOS. Add VisionOS as a supported destination for your app. The first step to updating your app is to add VisionOS as a supported destination. In your project settings, select your app target and navigate to the General tab. In supported destinations, click the Add button to add a new destination and select VisionOS option. Adding this option lets you build your app specifically for the VisionOS SDK. When you add Apple Vision to as a destination, Xcode makes some one-time changes to your project build settings. After you add the destination, you can modify your project build settings and build phases to customize the build behavior specifically for VisionOS. For example, you might want to remove dependencies for the VisionOS version of your app or change the set of source files you want to compile. For more information about how to update a target configuration, see customizing the build phase of a target. Okay, so we have the landmark app here that we have taken from Apple tutorials. And here in our app general and destinations, we have already added Apple Vision Pro to one of our destinations. We can then run this in our simulator. Here we are running a version of the Landmarks app as a iPad app. It's not looking very native at this point. There is no glass background, but it works. Clean up code that uses deprecated APIs. Fix any deprecation warnings in the iOS version of your code before you build for VisionOS. Apple marks APIs as deprecated when they are no longer relevant or a suitable replacement exists. When you compile code that calls deprecated APIs, the compiler generates warnings and often suggests replacements for you to use instead. VisionOS removed many deprecated symbols entirely, turning these deprecated warnings into missing symbol errors on the platform. Make changes in the iOS version of your app to see the original deprecated warnings and replacement details. In addition to the individual symbols, the following frameworks are deprecated in their entirety in both iOS and VisionOS. If your app still uses these frameworks, stop using them immediately. The reference documentation for each framework includes information about how to update your code. Accounts, Address Book UI, Asset Library, GL-Kit, iAdd, Newsstand Kit, Notification Center, and OpenGL-ES. Isolate features that are unavailable in VisionOS. The iOS SDK includes many frameworks that don't apply to VisionOS, either because they use software that isn't available or a feature don't apply to the platform. Move code that uses these frameworks into separate source files whenever possible, and include those files only in the iOS version of your app. When you can't isolate the code to separate source files, use conditional statements, such as the one below, to offer a different code path for VisionOS and iOS. The following example shows how to configure conditional statements to execute separate code paths in VisionOS and iOS. So if OS is VisionOS, then do this, else if iOS, do the other thing. Now, then we end the if statement. The following frameworks are available in the iOS SDK, but not in the VisionOS SDK. ActivityKit, Ad Support, App Clip, Automated Device Enrollment, Business Chat, CarKey, CarPlay, Cinematics, ClockKit, Core Locations UI, Core Media I/O, Core NFC, Core Telephony, device activity, dock kit, exposure notification, family controls, finance kit UI, manage settings, manager settings UI, messages, ML compute, nearby interactions, open AL, proximity reader, room plan, safety kit, screen time, sensor kit, service management, social, Twitter, widget kit, and workout kit. Some frameworks have behaviors changes that impact your app in VisionOS, and some frameworks disable features when the required hardware is not unavailable. To help you avoid using APIs for missing features, many frameworks offer API to check the availability of those features. Continue to use those APIs and take appropriate actions when the features aren't available. In other cases, be prepared for the framework code to do nothing or generate errors when you use it. ARKit, this framework requires you to use a different API for iOS and VisionOS. For more information, see Bring Your ARKit app to VisionOS. Automatic assignment configuration. The framework returns an error if you try to start a test in VisionOS. AV Foundation captures interfaces aren't available in VisionOS. Use availability checks to determine which service are present. CallKit, you may continue to offer voice over IP service, but phone number verification, call blocking, and other cellular related services are unavailable. ClockKit, the API of this framework, do nothing in VisionOS. Core Haptics, VisionOS play audio feedback instead of haptic feedback. Core Locations, you can request someone's location using the standard location service, but most other services are unavailable. Use availability check to determine which services are present. The always authorization level is unavailable and automatically becomes when in use authorization. Core motion barometer data is unavailable, but most other sensors are available. Use availability check to determine which sensors you can use. Health Kit and Health Kit UI, health data is unavailable. Use availability check to determine when information is available. MapKit, user tracking features that involve head information aren't available. Media Player, some APIs are unavailable in the VisionOS. Metric Kit, you can gather on-device diagnostic logs and generate reports but can't generate metrics. Music Kit, some APIs are unavailable in VisionOS. Nearby interactions, the framework does nothing in VisionOS. Use availability check to determine when services are present. Push-to-talk services are unavailable. Click check for errors when creating a push-to-talk channel manager. Safari services, a link that presents a SF Safari controller now opens a new scene in the Safari app. UI Kit, the system reports a maximum of 2 simultaneous touch inputs, one of each person's hand. All system gesture recognizers handle these inputs correctly, including for zoom, rotation gestures that require multiple fingers. If you have a custom gesture recognizer that requires more than 2 fingers, update them to support only 1 or 2 touches in VisionOS. Vision Kit, the data scanner view controller API are unavailable, but other features are still available. Watch connectivity, the framework supports connection only between iPhone and Apple Watches. Use availability check to determine when services are available. For additional information about how to isolate code to the iOS version of your app, run code on a specific platform or OS version. In our app here, we do not use any of those frameworks, so we have no warnings. Update your interface to take advantage of VisionOS features. After your existing code runs correctly in VisionOS, look for ways to improve the experience you offer on the platform. In VisionOS, you can display content using more than just windows. Think about ways to incorporate the following elements into your interface. Depth. Many SwiftUI and UIKit views use visual effects to add depth. Look for similar ways to incorporate depth into your custom views. 3D content. Think about where You might incorporate 3D models and shape into your content. Use Reality Kit to implement your content and a reality view to present the content from your app. See adding 3D content to your app. Immersive experiences. Present a space to immerse someone in your app's content. Spaces let you place content anywhere in a person's surrounding. You can also create fully immersive experiences that display not only your app's content, see creating fully immersive experiences in your app. Interactions with someone's surroundings. Use ARKit to facilitate interactions between your content and the surroundings. For example, detect planar surfaces to use as anchor points for your content. See ARKit. If you built your interface using UIKit, you can still load iOS storyboards into your app, but you can't customize your interface for VisionOS, including the 3D content. To include VisionOS content in your app, programmatically add your Swift UI views using UI hosting controller or UI view representable. Alternatively, migrate the relevant parts of your interface to SwiftUI. Moving your interface to SwiftUI gives you less code to maintain and makes it easier to validate that your interface does what you want. For information about mixing SwiftUI and UI content, UI kit content, see UI kit integration in SwiftUI. For guidance on how to best incorporate depth and 3D elements into your interface, see Human Interface Guidelines. Update your app's assets. Add vector-based or high-resolution images to your project specifically to support VisionOS. In VisionOS, people can see and can view your app's content at different angles and different distances, so image pixels rarely line up with screen pixels. Vector-based images work best because they maintain their detail crisp at any size. For bitmap-based images, use high-resolution images 2x or better to ensure your images retain detail at different sizes. For more information about designing images for your app, see Images in Human Interface Guidelines. Now, decide to port your app or not at all. In some cases, it might not make sense to port your app to VisionOS. For example, don't port the following types of apps. Apps that act as containers for app extensions. This includes apps where the primary purpose is to deliver custom keyboard extensions, device drivers, sticker packs, SMS and MMS message filter extensions, call directory extensions, or widgets. Movement-based apps that include apps that follow a person's location change, such as apps that offer turn-by-turn direction or navigation. It also includes apps that track body movement. Selfies or photographic apps. This includes apps where the primary purpose is to capture image or video from the device's camera. If your app uses an unsupported feature but can function without it, you can still bring your app to VisionOS, remove the feature that aren't available, and focus on bringing the rest of your content to the platform. For example, if you have an app that lets people write down notes and take pictures to include those notes, disable the picture taking ability in the VisionOS, but let people add text and incorporate images they already have. And with that, we have reached the end of the article of bringing your existing app to VisionOS.